previously discussed it being set up, which if you have not watched your pre-lab video right now, before this time, you're doing your videos in the wrong order. So, first off, we have our data table, and we need to set a position for photo gate A. What's really amazing about these ramps, every one of these marks on the ramp indicates 5 centimeters. So every time we move down our photo gate, one of these little marks on the ramp, we're moving it down 5 centimeters. We're going to assume that where the photo gate is here is position 0. So our position of photo gate A for our first trial is going to be at 0 centimeters. Next, I need to find what the time through photo gate A is going to be when I release my car from the beginning position. So I'm going to put my car here, I'm going to gently release it, and my photo gate tells me the time through photo gate A, my data collector does, which is 0.0121 seconds. Now Mrs. Lewis is going to explain how you calculate the speed of your car.
Okay, so folks, remember, our formula for calculating speed is going to be speed is equal to distance, I'm going to abbreviate that as D, over time. So let's take a look at some of the data points that we have for this first trial. Our distance, remember, is going to be 1 centimeter. And our time for this first run is 0.0121 seconds. So those are the two things that I'm plugging into my formula. So when I plug it in, I should have speed is equal to 1 centimeter divided by 0.0121 seconds. There's what it looks like with everything plugged in. So I'm going to take my calculator and I'm going to do 1 divided by 0.0121, and I should get my speed as 82.6 centimeters per second.
This is what you should have written down in your lab manual thus far, our data for trial 1 with our time and our calculated speed. Now we're going to continue our experiment by doing 5 more trials where we move the photo gate down to different positions down the ramp. And for right now, we're just going to acquire the time it takes for the car to go through photo gate A. After we collect all of our data, then we'll calculate the speed for each trial. Our trial at 20 centimeters. I actually can't go to 30 centimeters because the photo gate doesn't fit in the middle of these ramps by the way they're engineered. So I'm going to go ahead and head over to 40 centimeters. point in the experiment. Now please take the time to pause this video and calculate the speed of the car for each trial. This is what your data table should look like after you have calculated the speed of the car for each trial. Remember, you should be reporting your answers to 3 significant figures.
Alrighty folks, now that we have collected our data, we are going to take that data and analyze it. We're going to put it into a graph so we can actually visualize these trends and better be able to predict what the speed might be of the car at a point along the ramp that we did not measure. So first thing we are going to do is we are going to label our axes before we get started on anything else. You'll see up here that our y-axis should be speed, and the unit for speed is centimeters per second. So over on the left side, we're going to write down speed in centimeters per second in parentheses. Our x-axis is going to be labeled position of photo gate. The unit that we are using is centimeters. So on the bottom, write in position of photo gate. And in parentheses, our unit, which is centimeters. Last bit of setup in terms of writing that we'll do on the outsides is our title. So our title should be descriptive and explain what is the graph showing. So an example title that I'm going to title my graph is Speed of Car at Different Positions along ramp. Now, before we get started on plotting any data points, we have to create a scale for our graph. We have to remember a few rules, most importantly of which is that we always have to start at 0. Then we try to maximize our distance on the graph. So how can we fill out the most space along both our x-axis and our y-axis? And for that, we have to consider our data points. For the position of the photo gate, we have to go from 0 to 60. So we'll count our boxes here at the bottom. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we have 20 squares along the bottom. If we are trying to get to 60, to figure out how many each box needs to be in order to get to 0 to 60, we're going to take 60 and divide it by 20. When we divide 60 by 20, we should get 3. That means each box should be equal to 3 if we want to start at 0 on the left and end at 60 on the right. So we're going to take a second and make each box 3 and create the scale for the bottom of this graph. Alrighty folks, so we should have our bottom scale completed. Now let's move over to our y-axis scale. First, of course, we need to count how many boxes we have, and then we'll take a look at our data and figure out how much do we need to go up by in order to maximize our graph. So first we count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 25. So we have 25 boxes along the y-axis. And we need to go from 0 to 200, since that is our top speed. So, to figure out how much each box is worth, we take 200 and divide it by 25. When we divide those, we should get 8. So each box should be 8 as we move up along this y-axis. Let's take a moment to fill that in. Alrighty, look at this beautiful scale. We have gone from 0 to 60 on the bottom, and we've gone from 0 to 200 evenly along the top. Now all that's left to do is to go ahead and take a look at our data and begin plotting points. Our first point is 0 and 82.6. So we're going to go along our x-axis first to 0. Then we will go up our y-axis to 82.6, and we'll make our best approximation between 80 and 88, where 82.6 should land. And we'll draw a nice little dot there. We'll continue along for our next data point. Our next data point is 10. So we're going to move just a little bit over from 9, and our speed at that point was 110. Isn't that fancy? So we're going to go to 10 all the way up to 110, which will be just below 112. And we'll place our next dot in our graph. Next data point, 20 and 133. Same process. Let's find 20 along our x-axis and then move up to 133 along our y. Make our best approximation and plot that point. So once you are done plotting all of those points, your point should look like a nice straight line in this graph. And we are going to be using this graph to try to predict what speed the car might be at a certain point along the track. The best way that we're going to be able to do this is if we draw in a line of best fit. You'll need a ruler in order to draw this, or some other straight edge. When we draw a line of best fit, we want to do our best to try and get all the points on the line, but there's obviously going to be some that don't want to fit in that line, and that's okay. We do want to try and make sure that we have an even amount of points on the top and bottom of that line. So I currently have 2 points sticking out, or about 3 points sticking out above where I would draw my line with my ruler, but I also have about 3 points sticking underneath. So use your best guess and approximation to figure out where you want to draw that line of best fit. It is not as simple as just drawing from the first point to the last point. That's not necessarily going to give us our best line of best fit. So, take a second, fiddle with it, and once you feel like you have the best line, draw a nice bold line between the end of the graph and the start of the graph, remove it, and that is a line of best fit that we can use to predict the speed of the car at a position along the ramp that we did not measure. Okay, folks, so as we'll recall, our key question for this lab is, can we predict the speed of a car as it moves along a ramp? And you might be wondering, how the heck do I predict this? I don't have the tools to do this, when in fact you have created the tool to do this already by creating your graph on the next page. So if we were to predict the speed of the car at 45 centimeters along the ramp, we can do this. So I'm going to write the question at 45 centimeters, what is the car's speed? And let's see if we can answer that together. The way that we're going to do that is by using the line of best fit that you created. What we will do is we're going to line our ruler up with 45, which is the position of the photo gate on this x-axis, and we're going to take a look and follow this up until it hits our line of best fit. When it hits the line of best fit, we then go to the left and see roughly what point would that be along our y-axis. So to me, it looks to be about halfway between 168 and 176. So that means that our speed at this point along the ramp should be about equal to 172 centimeters per second.
Now let's test our prediction. We have the photo gate at 45 centimeters, and we need to use our data collector to find out how much time it will take for the car to pass through the photo gate at this position, which is 0.0057 seconds.
Okay, so now we're going to calculate to see if the prediction that we made was actually correct. So remember, the speed, or the formula for calculating speed, is distance over time. Our distance is still 1 centimeter, and in this case, our time is 0.00575 seconds. So when we plug that into our formula over here, we're going to get 1 centimeter over 0.00575 seconds. And when I do the math in my calculator, 1 divided by 0.00575, I'm left with a number that is 174 centimeters per second. Not too bad.
Head back to Schoology to complete this assignment where you'll be inserting a picture of a graph and writing a RAPS conclusion. Thanks everybody for listening, and have a great rest of your day.